Hello everyone, my name is Courtney Warren and this is my Cloud Security Capstone project. For this final assignment, I built a fully deployed production-style secure cloud architecture inside AWS. My goal was not just to stand up infrastructure, but to create a layered defense-in-depth environment that demonstrates real-world patterns, network segmentation, identity and secrets management, encryption, threat detection, traffic inspection, and automated response. In this presentation, I'll walk you through the architecture, the build process, the security controls, and finally, a live demonstration where we test the system with simulated attacks and confirm alerts, logging, and monitoring end to end. The architecture I created represents a secure enterprise-style three-tier web application designed around the principles of least privilege, network isolation, and centralized observability. End users access the application over HTTPS using a custom domain secured by AWS Certificate Manager. All inbound traffic enters through an application load balancer protected by AWS WAF, which provides the first line of defense against common web-based attacks such as SQL injection and cross-site scripting. The load balancer is the only public-facing component and resides in the public subnet, acting as a controlled entry point into the environment. From the ALB, traffic is forwarded to the application tier, which consists of an EC2 web instance deployed across multiple private subnets and availability zones. This instance does not have public IP addresses and cannot be accessed directly from the internet. Any outbound connectivity, such as patching or AWS service access, is handled through a NAT gateway to ensure controlled outbound-only traffic. The data tier uses a MariaDB RDS instance deployed entirely within private subnets with no public accessibility. Database credentials are never hard-coded or stored in the instances. Instead, they are securely stored in AWS Secrets Manager. The EC2 instances retrieve these credentials dynamically at runtime using an attached IAM instance role. This eliminates static secrets, supports rotation, and enforces least privilege access at the identity level. IAM roles play a critical role throughout the architecture. The EC2 instance role grants only the permissions required to retrieve secrets and publish logs and metrics. Lambda functions also operate under tightly scoped IAM roles, ensuring that automation actions are auditable and restricted to approved resources. Logging and monitoring are centralized to provide visibility across the environment. CloudTrail records API activity and configuration changes, enabling governance and forensic traceability. GuardDuty analyzes CloudTrail, VPC flow logs, and DNS data to identify potential threats and anomalous behavior. VPC flow logs capture network traffic metadata, allowing analysis of accepted and rejected connections, while CloudWatch aggregates logs, metrics, and alarms to monitor application health, traffic patterns, and security events in near real time. Finally, AWS Lambda is used as an automated response layer. When specific security or operational events are detected through CloudWatch or GuardDuty findings, Lambda functions can be triggered to perform predefined actions such as sending alerts, enriching logs, or initiating automated remediation steps. This allows the architecture to move beyond passive monitoring into active, event-driven response without introducing additional servers or attack surface. Overall, this design ensures that no internal component is directly exposed to the internet. Secrets are never stored in plain text, access is enforced through IAM rather than network trust alone, and security events are continuously monitored and actionable. To build the environment, I started with the VPC. I created a 10.0.0.0/16 network with 4 subnets, 2 public and 2 private. The public subnets host the load balancer and NAT gateway, while the private subnets host the EC2 app server and RDS database. I attached an internet gateway for inbound and outbound access through the ALB, and I created route tables to ensure the correct traffic flow. The public route table forwards all traffic to the IGW, while the private route table sends outbound traffic to the NAT gateway. Next, I deployed the EC2 application instance configured with SSM Session Manager instead of SSH for secure access. I verified that the Apache test page was running and that user data scripts were correctly applied. I then deployed the RDS instance configured encryption and restricted access to only the application security group. Secrets Manager stored the master credentials and the EC2 role was granted strict read-only access to that secret. To ensure secure communication, I used AWS Certificate Manager to issue a TLS certificate for my domain, as well as I included the CourtneyCloudFinalProject.com as well as the www prefix. After DNS validation through Route 53, I configured the ALB to terminate HTTPS at port 443 and forward decrypted traffic to the EC2 instance on port 80. At this stage, hitting the URL in the browser showed a secure lock, and both the root and www domain successfully resolved through Route 53 to the ALB, completing the secure entry pathway. One of the core security objectives of this project was to implement a web application firewall. I created a web ACL in AWS WAF and attached it to the ALB. I enabled multiple managed rule sets, including AWS Common Rule Set, Known Bad Inputs, SQL Injection Rule Set, and the optional PHP Rule Set. These rules provide protection against injection attacks, malformed headers, bot traffic, and common exploit signatures. The default action for the ACL is to allow traffic unless it matches a rule, in which case the request is blocked. I tested the WAF using controlled attack strings, like a simulated SQL injection payload. As expected, the system responded with a 403 forbidden error, and the block was recorded in the WAF logs. To turn this into a real operational security environment, I implemented a full detection and alerting pipeline. First, I enabled CloudWatch logging for WAF. Every blocked request is stored in a structured JSON format that allows detailed inspection. Next, I created a CloudWatch metric filter that looks for any log entry where the action equals block. This feeds into a CloudWatch alarm, which triggers whenever malicious traffic is detected. From there, the alarm sends an event to an SNS topic. I added an automated Lambda function as a subscriber, which parses the WAF logs, extracts the attacker IP, and the rule triggered, the URI, and the timestamp, and then publishes a neatly formatted security alert to SNS. Finally, SNS delivers email notifications, so the moment an attack occurs, I received an alert with all the relevant details. I had validated this entire pipeline by performing simulated attacks and observing the WAF block, the CloudWatch log entry, the metric filter count increase, Lambda invocation, and the eventual SNS alert. I also enabled AWS GuardDuty to provide threat detection across CloudTrail, VPC, flow logs, DNS logs, and IAM activity. This ensures ongoing monitoring for anomalous behavior such as credential misuse, reconnaissance, and suspicious EC2 network traffic. VPC logs were configured to capture accept and reject traffic, providing visibility into network paths and helping validate the segmentation between public and private resources. These services enhance the environment's observability and bring it closer to real-world security posture. In the end, the entire system performed exactly as intended. The secure architecture successfully routed traffic, HTTPS was enforced, private resources remained isolated, the WAF accurately detected and blocked malicious inputs, and the alerting pipeline delivered clear, actionable notifications. This project allowed me to integrate networking, identity, detection, engineering, and secure by design practices into one cohesive environment. It reinforced the value of layered defenses and demonstrated how each AWS service contributes to the bigger security picture.